Here we're given the function f of x equals 2 over x, and we are to find the difference quotient and simplify it. So I'm going to start by copying the function that was given in the problem, and notice in the difference quotient, f of x is right here. So in a moment, I will be replacing this notation f of x with what was given, 2 over x. But we need to make a substitution for what f of x plus h is. So I need to find out what that is right now. You find what f of x plus h is by taking the original function f of x and replacing the input variable x with the expression x plus h. One way to think about this is to copy the original function and just leave an open set of parentheses wherever you have the input variable x. So here there was an x and there was an x, and I left open parentheses in its place. Now, to get this part of the difference quotient, f of x plus h, I need only put an x plus h here in the blank, and whatever goes into this blank spot goes here as well. So what I have is, for this part of the difference quotient, f of x plus h, I will write this expression in its place, since that's what f of x plus h is. So I'm going to copy that down. Then it says to subtract, and then it says they want me to subtract f of x, which was given in the problem. It said that f of x is equal to 2 over x. So I'm replacing this notation f of x with 2 over x. Also notice the difference quotient has me taking all of that and dividing by h. So I've found the difference quotient. Now what I'd like to do is to be able to perform this division by h, I first want to actually subtract these two fractions. Remember, when you subtract fractions, you need to have a common denominator. So it turns out my least common denominator in this problem would have a factor of x, and would also have this factor of x plus h. So I need both of my fractions to have this denominator. So comparing what I want my denominator to be with what it is right now, you can tell I need a factor of x, so that this denominator matches what I want it to be. Since I've multiplied my denominator by x, I must multiply my numerator by x, and you could think of this as I've multiplied by the number 1. X divided by x can be simplified down as the number 1, and in math you're allowed to multiply by 1 because that does not change the value of an expression. Now this fraction has a factor of x in the denominator, but does not have the factor x plus h. So I'm going to multiply my denominator by a factor of x plus h, and I'll also have to do that to my numerator. Now that I have a common denominator, I can subtract these two fractions. So when you subtract fractions, you copy the common denominator. In my case, that's x and x plus h. And my numerator, I'm going to think of x times 2 as 2x. And I'm subtracting 2 times the quantity x plus h. And don't forget that all of this was being divided by h. Now, at this point, you may be tempted to do things like simplify this x and this x, or perhaps this quantity x plus h with that x plus h. The sole reason you cannot do this is because of this right here. Since these two expressions are being combined by subtraction and not multiplication, these things cannot be canceled. So what I must do now is continue to simplify. For example, I can distribute this negative 2. If I multiply negative 2 times x, I get minus 2x. Negative 2 times h is negative 2h. I will copy the common denominator, and don't forget that this is still all being divided by h. Notice now that the 2x subtract 2x is 0. That simplifies down. So what I'm left with is negative 2h in the numerator. Still have that denominator of x times the quantity x plus h. Also, you could think of this h as h over 1. And to simplify a complex fraction, this division bar right here gets changed to multiplication. And then the fraction on the bottom gets reciprocated, or flipped if you will. So that becomes 1 over h. So now if you bear with me and try to visualize this guy right here as being one single factor, outside the parentheses everything is multiplication. For example, the negative 2 is being multiplied by h, which is being multiplied by 1. The x is being multiplied by this factor, which is being multiplied by the h. So if you don't work with inside the parentheses here, you're allowed to cancel anything that is in common outside of that factor. So for example, I'm going to simplify this h and that h down and say that h divided by h is 1, and if you will, they cancel. But I want to point out that it would not be correct to cancel these h's because this h down here is being combined with another expression via addition. These would not simplify out. So let me cancel this h and this h, and that would leave me with negative 2 times 1 in the numerator And in the denominator, all that would be left is x and x plus h. So this would be the simplified version of the difference quotient. And you have to agree that that is much simpler than what we started with, which was this portion of what you're seeing right here. I would much rather look at this expression than what we started with. So hopefully that all made sense, and best of luck with your problem.